For decades, nuclear power has lived in a strange contradiction. It is one of the cleanest and most reliable sources of energy ever created, yet it has struggled to grow. Not because it doesn't work, but because it became too big, too slow, and too expensive to adapt to a changing world. In 2025, that contradiction is finally being challenged in a serious way. Because after years of design, debate, delays, and doubt, small modular reactors are no longer just a concept. They are real. They are operational. And at the center of this turning point stands one company that has been working toward this moment longer than almost anyone else. This is NuScale Power. And this is the story of how small modular reactors are finally going live. Here on Innovation Corner with Dan, we focus on the moments when theory becomes reality, when ideas stop living in presentations and start operating in the real world. NuScale's first commercial deployment marks one of those moments, not just for the company, but for the future of nuclear energy itself. To understand why NuScale matters, you have to understand what small modular reactor actually means, and why the word small is far more important than it sounds. Traditional nuclear power plants are designed to produce massive amounts of electricity, often enough to power entire regions. That scale sounds impressive, but it comes with severe drawbacks. Gigantic upfront costs, long construction timelines, massive political risk, and a brutal reality. If anything goes wrong, the consequences are magnified. NuScale approached nuclear power from a different angle. Instead of building one giant reactor, they designed a compact reactor module that produces a fraction of the power, but can be combined with others. One module, 6 modules, 12 modules, each one identical, each one factory built. Each one designed to be installed in a shared facility. This modularity changes everything. It allows utilities to start small and expand gradually. It reduces financial risk, it simplifies construction, and perhaps most importantly, it standardizes safety. NuScale's reactor design is built around passive safety systems. That means the reactor does not rely on active mechanical systems or human intervention to shut down safely. In abnormal conditions, gravity, natural circulation, and basic physics do the work. The reactor is submerged in a large pool of water inside a containment structure. If power is lost, the system cools itself. No pumps, no external electricity, no emergency improvisation. This design philosophy directly addresses the fears that have haunted nuclear power for decades. But design alone is not enough. Nuclear energy lives or dies by regulation and execution. NuScale spent years navigating one of the most rigorous approval processes in the world. Their reactor design was scrutinized, challenged, revised, and reevaluated. This process was slow, expensive, and exhausting, but it also gave NuScale something invaluable: credibility. By the time their first commercial project moved forward, it wasn't just a technical milestone, it was a regulatory one. And that's why 2025 matters, because this is the year when NuScale's vision finally steps into the real world. The first commercial deployment represents more than a power plant. It represents proof that small modular reactors can move beyond theory, that utilities can commit, that regulators can approve, and that nuclear energy can adapt to modern needs. But let's be clear, this journey was not smooth. NuScale faced skepticism from every direction. Critics questioned whether SMRs could ever be cost competitive. Others doubted whether utilities would accept lower output reactors. Some argued that renewables alone would make nuclear unnecessary. And then there were the delays. Timelines slipped, costs rose, projects were revised, partnerships changed. At times, it seemed like NuScale might become another promising nuclear idea that never fully materialized. But persistence matters. NuScale's advantage was that it never tried to sell a miracle. It sold a system, a conservative engineered solution built on known physics, improved safety, and modular scalability. That approach doesn't generate headlines, but it survives scrutiny. In 2025, as the first NuScale SMR plant goes live, the conversation around nuclear energy begins to change, not because of rhetoric, but because of operation. Once a reactor is running, producing electricity day after day, arguments become less abstract. Performance replaces promises, and performance is where SMRs shine. Small modular reactors offer flexibility that traditional nuclear plants simply cannot. They can be placed closer to demand centers. They require less land. They integrate more easily with existing grids. They can support renewable energy by providing stable baseload power when solar and wind fluctuate. This makes them uniquely suited for the modern energy landscape. And that landscape is changing fast. In 2025, electricity demand is not growing evenly. It's spiking in specific places: data centers, industrial hubs, and electrified transportation corridors. Large, centralized plants struggle to respond to these localized surges. SMRs, by contrast, are designed for precisely this kind of environment. This is where NuScale's modular philosophy becomes powerful. Utilities no longer have to bet everything on one massive project. They can add capacity incrementally, adjust plans, scale as needed. This reduces financial risk and political resistance, and reduced risk changes decision-making. We've seen time and again that industries don't transform when technology improves. They transform when risk decreases. NuScale's SMRs do exactly that. Safety is another major factor. NuScale's reactors are designed so that even in worst-case scenarios, the reactor naturally shuts down and cools without releasing radiation. This is not an emergency feature, it is the default behavior. That distinction matters for public trust. For decades, nuclear safety was explained as unlikely but manageable. SMRs shift the narrative to physically constrained and inherently stable. This doesn't eliminate fear overnight, but it changes the foundation of the conversation. Of course, challenges remain. Cost competitiveness is still under scrutiny. Manufacturing scale must be proven, supply chains must mature, and public acceptance will take time. But what makes NuScale's first commercial plant so significant is that it breaks the cycle of stagnation. For years, nuclear innovation was trapped in a loop of planning without deployment. NuScale has now crossed that line. And once one plant exists, others become easier. Regulators gain confidence, utilities gain data, investors gain clarity, and competitors are forced to respond. This is how industries move forward, not with sudden revolutions, but with irreversible steps. NuScale's success also sends a message to the broader energy sector. Nuclear power is not frozen in the past. It is evolving. It is becoming smaller, safer, and more adaptable. It is shedding the baggage of gigantism and embracing modularity, the same principle that transformed computing, manufacturing, and logistics. And that matters deeply in a world facing energy uncertainty. One more key point often overlooked is how NuScale's SMR model reshapes workforce and local economies. Traditional nuclear plants require massive, highly specialized construction crews for long periods, followed by complex operational staffing. NuScale's modular approach changes this dynamic. Factory-built modules shift much of the labor to controlled manufacturing environments, improving quality and predictability. On-site work becomes shorter, safer, and more repeatable, allowing regions without nuclear mega-project experience to participate. This lowers barriers for smaller utilities and creates a new nuclear supply chain built around manufacturing, logistics, and standardized maintenance. This may be just as transformative as the reactor itself, because energy transitions succeed when people, skills, and local economies can realistically support them. We often talk about resilience. SMRs contribute to that by decentralizing power generation, by reducing dependence on long transmission lines, by providing reliable electricity in a grid increasingly stressed by weather, demand spikes, and aging infrastructure. NuScale's first commercial plant is not the end of the story. It is the beginning of a new phase. A phase where nuclear energy is judged not by its past, but by its present performance. A phase where utilities have options beyond fossil fuels and intermittent renewables. A phase where nuclear power becomes a practical tool again, not a political liability. As 2025 unfolds, the success or failure of NuScale's deployment will influence decisions around the world. Other companies are watching closely. Governments are watching. Energy planners are watching. Because if small modular reactors work at scale, they don't just change nuclear energy. They changed the entire energy equation. This is not about replacing every power plant. It's about giving societies more choices, more flexibility, more resilience. And that's what real innovation looks like. NuScale's reactors going live mark a quiet but profound shift, one that could redefine how humanity generates clean, reliable power in the decades ahead, where we don't just track innovation, we follow it when it finally turns the lights on.